Okay, so in this video I want to do a few example questions on refractions at spherical surfaces. Alright, so this is not the part on lenses, this is just a single refracting surface. In other words, you have light traveling from a medium of one refractive index to another refractive index, and because you have two refractive indices, let's look at the equation that we have, right? So the equation I'm going to have is n1 over u, u being of course the object distance, n2 over v, which is the image distance, and then n2 minus n1 over r. Okay, so let's just have a bit of conventions, right? We want to look at conventions. That's not right. Okay, let's look at what we actually have diagrammatically. Oh. Okay, so let's say you have n1 here, right? It goes through some refracting surface, so let's say we have it convex, right? And then my r is obviously going to be on the opposite side, and then after this surface I have indices refractive index of n2. Okay, so how do we use this equation? Well, n1 is always where u is, or where the object is. So n1 is where the object is, whereas n2 is where the object is not. The object is not. Okay, so that's the first thing that you need to know. And then the second thing that you need to know in general, right, is that my r, because light passes through it, right, if you have light going into like that, what happens is it's going to pass through, right? So r is going to be positive when it is on the opposite side of incoming ray. Okay, so if I have my incident ray over here, incident ray, and then my r is on the opposite side, which is in n2, I'm going to have it positive. So in general, it is going to be positive when you have a when you have a convex surface. Okay, so what we want to do now is to look at a few example problems, right? And I will be focusing on let's see, I'll be focusing on past year papers, but of course that is not necessarily enough because there hasn't been much. So we are going to look at I think one pre-PSPM paper as well, just so that we have a more complete practice on it. Okay, so let's look at what we have, right? Fair enough. Okay, so I have a figure. This is a question from 21-22. I have a figure, right, where it shows a long rod with a convex surface, right? So this is convex. Okay, and it has a radius of curvature of 6 centimeters. If it is convex, as we've covered before just now, if it is convex, then my r is going to be positive. So I can immediately write down here that my r is going to be positive 6 centimeters. And then at one end, and is made from a glass with refractive index of 1.6. You see, if we look at the glass rod, do we have the object in there? The answer is no. So as I've said just now, n2 is where the object is not, right? So I can say that this 1.6 is, it's 1.6 is actually, is it n1 or is it n2? the object is not in the glass rod. Therefore, I will have n2 is equals to 1.6. Okay, and then the glass rod is placed in water with refractive index 1.33. So the object, as you can see in the diagram, is in the water. So that means that my n1 is equals to 1.33. Okay, 1.33. So an object is placed along the rod's axis to be imaged 53 centimeters inside the rod. Okay, so my v is positive, right, if it is on the opposite side of the object. So because it is 53 centimeters inside the rod and the object is not in the rod, I can say that my v is going to be positive 53 centimeters. Okay, so once we have read the whole question, we can now proceed with calculating using the equation or applying the equation to this question. Okay, so I have n1 to be 1.33. I have the image position is what I'm looking for, and then plus the 1.6, which is where the object is not, and then I have v, which is positive 53. Then I take the difference between 1.6 and 1.33 and then divide that by positive 6. And if you key this into your calculator, you will find that u is actually 89.8 centimeters. 89.8 centimeters. And that is your final answer for this question. Okay, so let us now proceed to the second sample problem that we're going to discuss in this video. Okay, the question given is from 1920, right? PSPM 2, 1920, right? And then it says that the figure shows an object and a glass rod immersed in a liquid. So where's the object? The object is in the liquid. So the liquid has N1. Okay, and then the rod has a refractive index of 1.7. We look at the picture and we ask, is the object in the glass rod? It is not. Therefore, I will say that N2 is equal to 1.7. Okay, and then it says, it continue on saying that the radius of the curvature is 8 centimeters. We have to be able to identify whether or not this is a convex or a concave surface. This is in fact a concave surface, which means my r is going to be negative. Okay, so then my r is going to be negative 8 centimeters, right? And the object distance is 15 centimeters. So then my object u is positive 15 because it's a real image, real object. And then a virtual image is formed at the distance of 13 centimeters. So that means my v, because it's virtual, remember it's virtual, is going to be negative 13 centimeters. And then it continues on with asking what is the refractive index of the liquid, which we have determined to be N1. Okay, so look for N1. Okay, so we can apply the equation here at this point, right? We can say that, okay, I have N1 over the distance of the object, which is positive 15, plus N2, which is 1.7, over the image distance, negative 13, because it's virtual. And then I have 1.7 minus N1 over negative 8. Okay, so if you key that into the calculator, what you are going to find is that refractive index of N1 is in fact 1.40 approximately. Okay, and that is my final answer for this question. Let's proceed to the next question. Okay, we are on the third question that I'm going to discuss in this video. This is from PSPM 2 1819. Okay, so let's just read the question. The figure shows an object embedded in a solid glass. So that means the refractive index of this solid glass is going to be n1 with a hemispherical end of radius 30 centimeters. We look at the diagram and we determine that it is a concave. How do I know it's concave? Because we have to measure, or we have to take a look at it from the object. Okay, it is going to be concave. Okay, so that means my r, if it's concave, is going to be negative 30. How do I know it's concave? Again, let me remind you, because we have to look at it from the perspective of the object. If I am the object and I look at the surface, I see a cave, or I see that the middle is deeper than the sides. Okay, so this is going to be a concave surface. Okay, and then this solid glass also has a refractive index of 1.5. So then I can immediately write down n1 is equals to 1.5. Okay. The object is 30 centimeters inside the glass, right? Sorry, 40 centimeters inside the glass. So that means my u is going to be positive 40. Right, and then of course the refractive index of air is 1. Because the object is in glass and not in air, I will have n2 to be 1. And now I'm looking for the image distance, which is, what is v? All right, okay, so at this point what you can do is you can apply the equation that we've had, right? We have n1, sorry, we've had n1, which was 1.5. Let me just change colors. There we go. Okay, I have n1, which is 1.5 over u, which is the object distance, which is positive 40, plus what is the medium that the object is not in, which is the air. I will have 1 over v, which is what I'm looking for, and then equal to 1 minus 1.5 over negative 30. Okay, negative 30. So again, I can quite easily have this input into my calculator. I will have that my v is equal to negative 48 centimeters, which means that the image form is much deeper. In fact, you have to add approximately 8 centimeters deeper into the glass. Okay, all right, so we will proceed to the last question that we want to discuss. Okay, so in this question, this question I've taken from one of the pre-PSPM papers. One of the colleges, I will not say which college is it from. All I can say is I'm just going to discuss the question. Okay, so let's look at the question. A sphere made of a material with refractive index of 1.5 contains a small bug from the center as shown in the figure. Okay, so where is the object? The object is the bug, right? Since the bug is in the material of refractive index of 1.5, I can confidently write down that my n1 is going to be 1.5. okay, and it's position 1.5 centimeters from the center. Okay, but that doesn't tell you that that is the distance from the surface. Okay, so then we have to continue on reading. Given that the radius of the sphere is 4 centimeters, you see, the total distance from the surface to the center, which is the radius, is 4 centimeters. Okay, which means u is over here. This is u. Okay, let me just highlight that. This is u. Okay, so I can write down that u is in fact 4 centimeters minus 1.5 centimeters, which is in fact 2.5 centimeters. Okay, so now the question is asking what is the position of the image of the bug as seen by the observer from left of the surface X. Okay, so I'm looking for V. Because the question doesn't say what is the refractive index of the observer, we will assume that the observer is in air, and air has a refractive index of 1. Air has a refractive index of 1, which means that N2 has a refractive index of 1 because the bug is not in the air. Okay, all right. So and the radius, right, it will have a magnitude of 4 centimeters, but now we have to determine whether it's positive or negative, right? So to do that, we have to move again from the object. Right, we will see that the bug will actually look at a concave surface. Okay, a concave surface. We look from the object, we see that it is concave. Okay, so if it is a concave surface, we will find that our R will actually be a negative value. Okay, so now we can substitute these values into the equation that we have before this. So let's just do that, right? So I have 1.5 over positive 2.5 plus 1 over V equal to 1 minus 1.5 over negative 4. Okay, so take a minute, or take a second or two to have this as your input into your calculator and press enter, and what you will find is that your V is in fact equal to negative 2.10 centimeters, which means that the image formed is going to be a virtual image. Okay, and if it's a virtual image, it's going to be formed in the material itself, not in air, not same side as the observer. Okay, so that is all the questions I'm going to discuss in this video. That was 4 questions. Hopefully it was helpful. Thank you very much.